Good morning everyone, and welcome to this morning's first session on the iron cycle. I'm very pleased to be joined today by a distinguished panel of experts. We've got Antonia Gray from the BMRA, the British Recycling Metals Association. We have Professor Zushu Lee from the University of Warwick, and we were meant to have Richard Curry, but unfortunately he's unwell today. But we do have a last-minute substitution from Dr. Cameron. So there's a great depth of expertise, and we'll have a great discussion today. And the discussion is on the iron cycle. So we'll be looking at the processing of steel, of scrap, the implications for steel making, and the novel solutions or compromises that will be needed to make the cycle work and produce the net zero steel that we need. So I'm here as chair of this panel, so I'll be brief, just kind of setting the scene, but also as UK Steel, I'm representing the steel makers in the UK, and I can definitely say that scrap is definitely a very hot topic for us, certainly in the last year especially. It's really crept up in its our appreciation of kind of its significance and how much more important it's going to be going forward, but also very conscious of all the changes that are going to be needed to transition to a more fully circular model of steel making. And so it's very interesting to see all the research that is ongoing around all these topics of dealing with residuals and all the kind of various changes and innovations that will be needed, as I said, to make that transition fully work. So the day that Tata Steel announced its plans to replace its blast furnaces with an electric arc furnace, and then not too much longer British Steel also announced similar intentions, the debate really roared around whether primary steel-making capacity is necessary in the UK, what are the limitations of scrap-based EAF steel-making, and within that there was a wild array of myths and misconceptions, which certainly we tried to address some, but there's definitely some valid questions in there. I mean, the truth is that we are increasingly looking to make types of steel products that have traditionally not been previously made through the EAF route. And while in principle, and the more technical people will correct me if I'm wrong, but in principle, all types of steel can be made through using scrap. However, it does become much more complicated. You need tighter controls on your scrap quality, tighter controls on residuals, and on the steel making process itself. And so it becomes more complex, more costly, and therefore in the past, typically producers would have chosen perhaps not to make flat products through the EAF route. But today we are looking at, being able to make, as I said, that kind of full range of, low emissions steel. And so there's a lot of discussion around this, and clearly access to scrap is very important, but also what's emerging is the fact that access to the right quality of scrap is also key. Now the UK produces just over 10 million tonnes of scrap every year. It varies slightly, obviously, but that's the general figure, and most of it gets exported at the moment. And of course, that's largely because the UK steelmakers just cannot use much more of this scrap, or yet. The intention is for that to change, but at present that can't be used. And of course, in recent decades, steel production levels in the UK have also dropped, which have also contributed to this lower scrap usage. However, the transition to green steel making, to EAF steel making in the UK and abroad is expected to see demand for scrap to skyrocket, and at the same time, ore metallics supply is also expected to be in short supply. And so there's a real this kind of question of raw materials becomes increasingly important in net zero steel making. Now, at the back end of last year, we as UK Steel, we published a report on scrap, and there we estimated that scrap consumption in the UK could treble by 2050. And then globally, there's a number of estimates that see a 30% increase in scrap consumption by 2030 and over 60% by 2050. So again, this kind of really highlights that sort of the trend and the importance of the access to that raw material. Now, there's clearly scope for improvements at each stage of this cycle, and looking at early on from the product design, whether it's the design of vehicles or buildings, to make them more easy to disassemble and separate all the materials and be able to recycle them more efficiently, to then the actual steel making process itself and the metallurgy side of things and how to deal with residuals at that stage, to finally the actual scrap collecting and processing and sorting. And at each stage of this cycle, there's changes that will need to be made, as I said, to make that circular model work. And so hopefully that's just kind of set the scene for the more detailed presentations to follow. But I'll just end by saying that while there's a lot of challenges in this transition, the transformation of the steel sector also presents a huge opportunity to drive innovation, to develop our recycling and processing capability, and to transition to a more circular model of steel making. The UK is in a great position in many ways. We're uniquely placed through access to academic excellence, which this conference and all you are testament to, and also access to an abundance of scrap. And so hopefully in the next few years we can really capitalise upon these strengths. And so on that hopefully optimistic note, I will hand over to our first speaker, Antonia. The floor is yours.
Good morning, everybody. I'm going to take you through a quick overview of what the British recycling industry looks like. As you can see, we comprise something like 2,000 regulated businesses. We employ around 15,000 people. In terms of worth to the UK economy, it's somewhere around 7 billion. And we, as Chrysa said, we export 80%. One of the reasons we export 80% of the scrap, which is a globally traded commodity, is because, as Chrysa said, there is not a domestic demand. A couple of other issues that we face as an industry is illegal operators. There's a lot of people jumping on the gun, recycling scrap not to a good quality, and they're not being regulated either by the local authorities or by the Environment Agency. The other issues we face is we are a highly regulated industry, and we face a lot of operating costs. So a bit about the British Metals Recycling Association. We have around upwards of 300 members. Our members will move around 90% of all scrap in the UK. They're different sized businesses. You know, the scrap industry is like a triangle. You have the collectors, and then you have the sorters, the processors. You'll get people that will start to bale, to granulate, and then onwards, upwards to shred to supply the steel industry. Just quickly, as I said, activities, collecting, sorting, baling, shearing, there's a lot of processes involved. So, recycling materials to produce a secondary raw material. Now, you've got Cam and Zushu who are going to do the academic bit, look at where the issues and how we can improve. But I thought it might be interesting if we look at one of the biggest components of scrap that goes into the steel industry, and that's end-of-life vehicles or cars. So what goes into the average car? Well, around 65% of it is ferrous metal. 95% of the whole car is recyclable. What else is there? There's aluminium, there's copper, there's plastics, there's glass. As one of the poster presenters alluded to, you've got lots of CRMs, rare earth metals, and the magnets in the batteries, and it's hard to capture. One of the biggest issues we have is we don't know where these, at the moment, we don't know where they are. There's a system called IDIS that the manufacturers of vehicles should be uploading all the details on, But the idea is it's okay to say they're in the car, not necessarily where they are in the car. So there may be magnets in the steering wheel, there may be magnets in the speakers, you may have lithium-ion batteries dotted all around the car, in the seat heaters, in the window operating things, and we just don't know where they are. So it's hard to find them, it's hard to get them out, you know, as the gentleman said, it can be quite time consuming to get them out. So, robotic dismantling. If I've heard it once, I've heard it 1,000 times. Why don't you just get robots to do it? They're built by robots, surely robots can dismantle them. Well, in 2005, which is sort of takes us up to this state where our cars are reaching end of life, 2.8 million cars were sold. The average car has around 30,000 parts. Now, that is just an example that I could come up with while I was writing this presentation of the different makes. All those makes have different models, they're all different sizes. When you go into a car assembly plant, they are designed for 1 or 2 models. They move around, they're putting things together, they're all fresh, nice and clean. After 15 years, there's a lot of corrosion, the bolts will be solid. It's incredibly challenging to get one robot to identify the car, to identify the model and identify the age. So you see there's a lot of variables of that robot. However, I'm not saying it won't happen, I think it will, but right now we don't have an iPhone and it's Emily. We just have a challenge to try and get past these issues. So, we have to manually depollute it at the moment. There's a lot of stuff that we are obliged to take out of the car before it goes into the steel making process. So, take out the batteries, you have to deploy the airbags, you have to take out the LPG cylinder if it's in there. All of these things can cause deflagrations if they're left in and go through a shredder. There's many hazardous materials we have to take out. We will take out the oils. The fuels will probably be reused by on-site, but a lot of it has to be dealt with by special hazardous companies. Again, it's very labour intensive. So the next step is it gets sent, and once it's depolluted, it gets baled or crushed. This is a baler at work. So you'll see stuff going in, having been crushed. Then there's the brute force of the baler coming out, and you'll see a car coming out as a bale. These are then sent up to the next process, which is to go into the frag. So, fragmentizers. Enormous bits of kit, lots of heavy hammers, and extremely effective at reducing sizable bits of steel and other metals into small fist-sized pieces of metal. Excuse me. So there's 3 streams that come out of a frag: ferrous, non-ferrous, and metal shredder residue. The ferrous obviously comes out first, usually through something like an eddy current separator, which interestingly enough was invented by a guy called Tony Bird of the Bird Group, luckily the Sims Group, who was in South Africa at a mining site, and he saw the potential of what was being used there and turned it into the eddy plant separator. The non-ferrous and the metal shredder residue will both go for further separation. Obviously we want to get as much of the non-ferrous out because that's where the high value is. The ferrous, as you all know, is not a high value product in terms of a commodity. It's just a good commodity. What we can't get rid of, and that tends to be a smaller amount, that will either go to landfill or for high temperature incineration. It's worth mentioning that some companies have a pre-shredder. Much of that is to deal with hidden LPG cylinders, hidden canisters, anything that might cause a deflagration or any sort of fire issue in the frag. So I mentioned costs. There's a lot of costs involved when it comes to running a scrapyard. You have to have environmental permits. If you've got a fragmentizer, you fall under the Industrial Environmental Directive, so you have to have a whole load of slew of other things you have to do in terms of monitoring, stat monitoring, air monitoring. The yards have to have sealed surfaces, they have to have drainage, they have to have interceptors, they have to have water capture tanks. We also need to have bays to separate out piles. You have to have water storage tanks in the event of fire. So there's a lot of infrastructure costs going into a yard. We also have the issue where at the moment a lot of our equipment, whether it's a 360 grab, a shredder, a fragmentizer, is powered by diesel. We lost our entitlement to red diesel about 3 years ago, and that really made an impact on many operators, because one site overnight their operating costs went up £2 million just through having to pay the tax on the diesel. There is electrification available, but most of it is not able to handle the weight involved. So obviously a standard container will have about 25 tons. Most electric HGVs can't deal with that. Any mobile bit of kit like a forklift or a grab generally has to be tethered, because the hybrid can't handle the weights and the sheer aggressiveness of the area, and you can't have a tethered umbilical running around in a scrapyard because there's lots of sharp things. The other issue we have at the moment is that a lot of sites are either rurally located or in industrial zones, and they either are not connected to the grid or they cannot draw enough power. So one of our members was quoted £2 million to connect to the grid, and another member who was connected to the grid and needed more transformers was quoted £70,000 per transformer. So there's a lot of operational costs. Obviously, like everyone else, we have personnel costs. We do have high-skilled people in there. I don't know if you've ever sat and watched a guy or a lady operating a 360 grab. They are artists, and they are paid accordingly. On the flip side, we have costs relating to disposal. Obviously, at the end of the processing, we have our shredder residue that has to go into to landfill, so the cost there. That has recently been classified as hazardous, so that will have to go into a hazardous landfill. So that increased the costs there. You have to get rid of the tyres from the cars, also the fluids that we can't reuse, and the fuels and the oils. So there's a lot of costs involved, and I think I've heard the argument that we could process more and make money from the non-ferrous, but unfortunately the margins are really small for the ferrous element. However, it's really exciting times. I've been to a lot of different sites, a lot of different operators in the UK and Europe, and we're really seeing some great processes coming in that are doing well, particularly dealing with the copper, getting the copper out. There's a lot of focus on that. So I think it's exciting. It's exciting for us as a national industry to see our own national industry grow and to have the opportunity to supply into electric arc furnaces and not have to export, because we are part of the decarbonisation. We are a key part of that. And if we don't have to export and we can just take it up the road, albeit on a truck, that is great. It's a great story, and I think everyone in the industry is really proud to see this and excited to what's coming next. So I think then it's over to my colleagues to actually do the more technical bit.
I'll try to complement the input that I've had from Antonia and Zushu there and talk about what Rich wanted to talk about, which was UK scrap quality and volume and its potential as a raw material for all steel grades, which I've selectively emboldened there for a hidden message. Okay. So this has already been covered, and I'm not going to waste a lot of time repeating things that people have already said, but essentially the UK is going to do something we're going to be focused here, yeah? And then the question is, what role is this stuff over here going to play? And bearing in mind Jonathan Reynolds' comments on, at least in the short term on Sunday morning, is this going to play a role in the short term or not? We don't know, right? So we have a scrap-based approach in the UK, and there's a very good reason for that. For the first time almost ever, we've actually got a competitive advantage in the UK, yeah? Because we're sat on a plentiful supply of raw material. If you're going to build a steelworks, traditionally you build it on the top of an iron ore mine. Yeah? And what we actually have is a massive urban mine that we can exploit. So for the first time ever, we've got a strategic advantage and we need to take hold of it. There is a prevailing sentiment for DRI, hydrogen DRI it's called, although I would guess that most of those furnaces will run on NG for a very, very significant proportion of their entire life, if not the entire thing. And as you start in the EAF to increase the amount of DRI that you put into the process, it starts to converge on a range of BOF-rated emissions from integrated plants anyway. Yeah? So there's perils in terms of holistic sustainability, both in terms of the available material, and Zushi's already highlighted that, from a dilution perspective, and also a environmental sustainability point of view, as you start to dilute the materials more and more and more to hit certain grades. Yeah? So it's all pointing to the thing that all of the contributors have been discussing. By the way, I obviously wrote these slides because I didn't do the pre-meeting with these guys. I didn't know what they were going to say. So I'm going to skip over some of these things because they've already been reinforced. Yeah? But there's loads of material in the UK. I think that's very well known. And the fact that the scrap quality is poor is something that's misunderstood. So I'll call this in scientific terms kind of like a null hypothesis. The null hypothesis is scrap quality is poor. Now, if you just do a finger in the air approach for UK available material and you say, historically, what have we bought and what type of steel is it? You can break that down into roughly 70% BOF steel and then a range of different EAS steels at slightly different concentrations. We're using copper here as an indicator, but of course we need to talk about all the elements as was highlighted earlier on. And then you can funnel this back to look at where it sits in the diagram that Zushu presented earlier on, which you're already now familiar with, which gives you the idea of what the residual tolerances might be for some of these different grades. And if you look at this, the finger in the air, the hypothesis for the UK, then actually you think, well, there's actually a large amount of material that can deliver almost all of the products. So why is it, colloquially, we're saying UK scrap quality is poor? And how do we understand what's going on there? So the challenge that we have in steelmaking is essentially that we've been really, really good at this. So I talked to the aluminium guys and they, about 5 years ago, and they said, oh, we're super jealous of steel because of all of the product development that you've done. Yeah? You've done all this product development, you've done all this specialisation. You've been really, really competitive in this space, and in the aluminium sector, we're still using the same old grades we always used to use. Yeah? But of course now, they're like, haha, our life is much easier, because what we've done is we've generated lots and lots of grades that have actually quite narrow processing windows eventually, right? So what we've done over that development cycle is narrow the process window, making it less and less flexible. Yeah? The steels become higher and higher quality, but they become harder and harder and harder to produce. And then at end of life, it kind of goes into a big pile, and then we put it back through, and when we put it back through, we carry these elements, particularly copper, nickel, tin, and chrome, that we don't necessarily want to be in there back into the process. And if you start to do a forensic characterization of the sorts of things that you might tend to see, then you will pick out all different types of material, and not just metal even, but also bits of clothes, lots of soil, these sorts of things. Okay. So we've got this extrinsic contamination problem, and what do we do to solve that? Well, at a very high level, I think everybody would agree that we need to stop chucking the elements back into the product development cycle. We need to stop chucking it in a pile. We need to use some method of being able to monitor the inventory of material as it flows through the economy, and then we need to map the flow of elements. This is just one example chart that I've just thrown in at the last minute, okay, but we need to map the elemental flow so that it goes back into here. And when we develop these products, as Zushi was highlighting earlier on, and there's a lot of good work that's been going on this on the development side we're going to be talking about later on, we need to develop products that are more robust. Yeah? the point of differentiation is no longer the conventional banana curve. Yeah? Actually, the first question that a lot of people will be asked now when they supply a product is, what's your proportion of recycled content? Yeah? So the differentiator now will be, for a certain grade specification, how much recycled content can you get into there? And that's quite a different thing. We need to work with the customers to build new specifications for more robust products. So that's the solution. The current steel scrap specifications, Antonia, look something like this. Is a summary, but look something like this. This is from your own document that you co-created with UK Steel. And they look something like this. And I think it's fair to say, isn't it, Antonia, that these are largely qualitative, and it's built on a, we kind of have an idea of roughly what we think the composition of those things will be, but they're not measured in any objective way. They're kind of, we know what the feeds will be, and they fit a certain standard. But these are quite qualitative standards of scrap quality, I think it's fair to say, isn't it? Yeah. And so we've done some work looking at one, which is 3B, which is one of the forms of fragmentized scrap that Antonia was talking about earlier on. And the challenge of fragmentizing, as was highlighted by both the previous speakers, is that you can actually get a relatively tiny piece of copper into a relatively large amount of steel and generate a contamination that starts to approach the residual limits in the standards that Zushu highlighted earlier on. Okay, so actually, we have a significant problem with what we'll call extrinsic and intrinsic contamination. So the first thing we need to do is discuss those two things completely separately. Yeah? When we say scrap quality is poor, we need to differentiate between what we consider to be poor as a result of extrinsic contamination, stuff in there that shouldn't be there, that isn't steel, isn't a certain grade, and intrinsic contamination, the stuff that is actually being baked into the steel through the steel making process. So to understand what's happening with this and how we can learn from international best practice, Sustainer sent Richard Curry on a tour of different countries, so Canada, the US, Germany, Poland and Belgium, to look at different scrap processing facilities, and in the same way that Zushu has done, tried to learn at an international best practice sort of level what we can get out of that. And trying to understand and make recommendations back to the Sustain Consortium of what we see. And at a very high level, Richard has summarised this like that. These are frame grabs, by the way, so these are his words, not mine. But essentially, the UK, we've got high quality, intrinsically high quality scrap. But we have an export-driven market. There's a very good reason for that Chrysa already highlighted, which is that in the UK there's not enough domestic demand, and certainly not enough domestic demand at a high enough price or a high enough quality. Okay. In the US and Canada, which is kind of oft-touted in the public parlance as sort of like the leader, yeah, the thing that we need to follow in the US, are obviously now about 70% EAF by production, and they will and they have an intrinsic contamination based on the studies that we've completed to date of about 0.12 copper. Again, so using copper as the indicator here, but we need to consider all of the elements. And then in mainland Europe, actually the demand for high quality scrap is a lot higher. The organisation of the supply chain, or the agreements of the quality metrics between the supply chain of the steel makers and the scrap suppliers is slightly better, and their intrinsic contamination still remains relatively low down here. But also we have to remember that they have relatively similar proportions of integrated base production and consumption as the UK. Okay? So their inventory of material is actually remarkably similar to our own. So why is the US standing out? Well, they've taken this dilution methodology, okay? So this is a slightly more detailed look. I don't want you to absorb it all really at the principles that Zushu was introducing earlier on, which is around the ore-based metallics and what level of dilution we think we would need to hit to get various different qualities. So this is the sort of scrap quality that you would have, so the amount of copper, extrinsic copper that you have in the scrap, and then this is the amount of dilution that you have to put in, and then this is what you'll get out as a function of all of that. So you can see there are numbers that are as high as 50, 60, 70 or even 80%. So very, very high levels of dilution for higher in extrinsic contamination of the material. And that drives us, if you can remember on my early slide, towards a point of intersection between traditional integrated manufacture anyway. Yeah? So once you get to those levels of dilution, you may as well just produce this through an integrated route because it's cheaper. Yeah? So, and that's driven by the availability of natural gas, making DRI a good option. And so what's happened as a result of that is that through several life cycles, because the US have been at this for a long time, they've been sequentially increasing the intrinsic contamination of their scrap. Yeah? That's a hypothesis that we've been able to confirm by actually looking at the quality of the material that's coming back through the economy. Okay, so their split through their inventory looks quite different to ours because they're already a long way down this path. So there's something there that we can learn from, and it is that the US is not necessarily the leader. We could be the leader because there are mistakes that they've made that we can avoid. I think that's quite important. But how are we going to validate this hypothesis and how do we measure that? Well, that's what we've been trying to do for quite a while. So we look at these large piles, and then there will be an assumption based on things like central limit theorem and other things that you would get a relatively smooth probabilistic distribution or a normal distribution of elemental concentration as a function, as long as your pile gets big enough. That's basically what central limit theorem says. So if you've got a big enough pile, you'll get a normal distribution. But if you actually look at the population, so you actually start to look, you actually start to measure, and we're doing this through a program called Rectify, which was actually kicked off by Stephen over there before he moved on to bigger and greater things over in Coventry University. And this is where we've actually looked at this. So if you start to separate the contents of the scrap by different attributes, and we're talking primarily here about the intrinsic concentration of the scrap rather than the extrinsic, so I'm making some assumptions about our ability to use industrial scale processes to liberate a lot of that extrinsic contamination, then we see actually here that a relatively large proportion of the material is relatively low residual. Yeah? It's just when you zoom out and you look at this aggregated figure for the whole thing, our distribution is skewed more this way than it should be because of a limited amount of, by mass, of extrinsic contamination. And when you compare this back to our, what we call a confidence in estimate approach, so these are terminologies actually used by the mining companies, okay, rather than position and uncertainty range when they're prospecting, which is what we need to do with the available material in the UK economy. If you compare this back with a confidence in estimate and you look at these different types, you'll see actually relatively good agreement for this individual scrap type that we've been looking at, the 3B material, between the hypothesis, which is we should have about 70% of the material below 0.05 weight percent copper, and what we actually measure. So we've taken the time to actually measure it, and we're validating the fact that that material of that intrinsic quality does actually exist in the UK economy, and therefore we do have this incredibly strong strategic advantage on which we can build the future of the UK industry, subject to the other technical challenges that were highlighted earlier on. But the fundamentals are there. So this is a really exciting time for the UK steel industry. And the levels of dilution that we may have to do could be significantly less. That means we'll get less enrichment through life cycles, but it also means when the customer comes to us and says, what's your recycled content, our number will be higher than the competitor and we will sell more. But how do we deliver on this opportunity? Well, there's a really useful report written by some of my colleagues in the ETC called Stealing Demand. I suggest you go and read it. And it examines how you develop a customer-driven demand for this transition. Okay? So we've discussed a lot about the challenges of cost. Antonia mentioned that it's really difficult to drive the investment if the domestic value proposition is low. You know, there's good volume in the export market, but again, they're necessarily not willing to pay for quality. So it's difficult for the scrap producers to justify investment in their capital equipment to be able to deliver these levels of quality from the intrinsic quality that exists. And on the similar side, we don't necessarily, as steel makers, they find it hard to sell material at higher prices because it's difficult to find that value proposition. Okay, especially with under the current circumstances. So we're scrabbling around trying to find value, And that's creating, let's be honest about it, tension between the scrap suppliers and the steel makers. But if you zoom, and then this is leading to, I'll say, tense discussions about a policy solution to this and how we might get that to work and all of this sort of stuff. But the interesting thing is if you look at this report and you look at, just zoom out slightly from the microcosm which is out of the steel companies and the scrap suppliers sort themselves out, and you look at the customer, take construction, huge volume, yeah, emissions due to steel pretty large as a percentage of their total emissions footprint, cost of increasing away from primary steel or increasing the cost of going to low carbon steel on a per building, per car, yeah, per consumer, per fridge basis, these are actually tiny. These costs are tiny. These costs to the consumer are tiny, but the value proposition of being a custodian, of being a part through consumer behaviour of the circular economy is enormous. So actually the value does exist, but we're not going to solve it on our own. The only way that we're going to be able to drive towards this destination of a mutually beneficial value proposition across the supply chain is by involving those customers. And if we do that, we'll be able to find the right price point all the way through. Everybody will make the right investment. The steel companies will make the right levels of investment. The scrap suppliers will make the right levels of investment. And then we will become a global leader in the circular economy. So the data is there, the fundamentals are there, and all we've got to do is pull it together and deliver. Yeah? And we're on the cusp of something genuinely special in the UK. Okay? And yes, we've got all of these immediate challenges, and I made some comments about that yesterday. I don't want to overlook that. And I find that really frustrating because we're actually not very far away from, I think, an explosion of investment in this sector in the UK. Not very far away at all. So, the perception is false. We do have a lot of high quality material. There's a significant difference between intrinsic and extrinsic contamination. Where there have been higher rates of recycling and dilution, they've created problems for themselves in terms of intrinsic contaminations, and we've done actual measurements both in the UK and a foreign material to confirm this. And to deliver on this UK opportunity, we've got to zoom out from just the scrap supplier steelmaker mentality or picture, and then look at this with the customers involved as well, which many of you know is exactly what I've been trying to do for about the last 3 months. Thank you very much.